Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive tutorial on getting started with unit testing in Visual Studio 2022 using nunit. We'll cover everything from setting up your project to writing and running your first tests, and then move on to more advanced concepts. What is unit testing? Unit testing is a fundamental software testing technique that focuses on testing individual units, example methods, classes, or small components, of your code in isolation. The goal is to verify that each unit functions as expected, independently of other parts of the system. Why unit testing matters. Early bug detection. Identifies defects early in the development cycle when they are easier and cheaper to fix. Code quality. Encourages better code design by forcing you to write testable code. This often leads to cleaner, more modular, and more maintainable code. Regression testing. Provides a safety net to ensure that new code changes don't break existing functionality. Documentation. Unit tests can serve as living documentation, illustrating how your code is intended to be used. Refactoring. Confidence. Allows you to refactor your code with confidence, knowing that you can quickly verify that you haven't introduced any regressions. Setting up your project in Visual Studio 2022. 1. Create a new solution. Open Visual Studio 2022. Click Create a new project. Choose Console App, or Class Library, ASP.NET Core Web API, etc., depending on your needs. For this example, we'll use Console App. Click Next. Give your project a name, example My Awesome Project, and choose a location. Click Create. 2. Add an nunit test project. In Solution Explorer, usually on the right side, right-click on your solution, the top-level node with the .sln extension. Select Add-New Project. In the Project Template search box, type nunit and select nunit test project, or nunit test project, .NET Framework, if you're targeting a .NET Framework version. Click Next. Give your test project a name, example My Awesome Project.tests. It's a good convention to name it after your main project with .tests appended. Click Create. 3. Add a project reference. In Solution Explorer, right-click on your test project, My Awesome Project.tests. Select Add Project Reference. Check the box next to your main project, My Awesome Project, to add a reference to it. This allows your test project to access the code you want to test. Click OK. 4. Install required NuGet packages, if not already installed. The nunit test project template generally installs these packages, but double-check. Right-click on your test project, My Awesome Project.tests. Select Manage NuGet Packages. Go to the Installed tab. Ensure that the following packages are installed. nunit. nunit 3 Test Adapter. Microsoft.NET.Test SDK. If any are missing, go to the Browse tab, search for them, and install them. Make sure the versions are compatible with your .NET runtime. Writing your first unit test. 1. Create a class to test, in your main project. In your main project, My Awesome Project, create a simple class. For example, 2. Write a test class, in your test project. In your test project, My Awesome Project.tests, create a test class. Typically, you'll create a class with the same name as the class you're testing, but with tests appended. Explanation asterisk. Asterisk using nunit.framework, imports the nunit attributes and assertions. Asterisk using myAwesomeProject, imports your main project so you can access the calculator class. Asterisk test fixture, an attribute that marks the class as containing test methods. Asterisk private calculator underscore calculator, create a private variable of type calculator. Asterisk setup, an attribute that marks a method to be executed before each test method in the class. This is where you typically initialize objects or set up the environment for your tests. We initialize the underscore calculator here. Asterisk test, an attribute that marks a method as a test case. Nunit will execute these methods when you run your tests. Asterisk arrange, act, assert, AAA a common pattern for writing unit tests. Asterisk arrange asterisk set up the data and objects needed for the test. Asterisk act asterisk execute the code you want to test, example call the add method. Asterisk assert asterisk verify that the result of the action is what you expect. Asterisk assert.AreQual, expected, actual, a common nunit assertion. It checks if the actual value is equal to the expected value. If they're not equal, the test fails. Asterisk assert.throws argument exception, equals underscore calculator.divide, a, b. This assertion checks that the divide method throws an argument exception when dividing by 0. The equals is a lambda expression. Running your tests. 1. Build your solution asterisk make sure your solution builds successfully, build solution. 2. Open the Test Explorer asterisk go to test-windows-test explorer. The Test Explorer window will appear. 3. Discover tests asterisk Visual Studio should automatically discover your tests in the Test Explorer. If not, click the refresh button at the top of the Test Explorer. 4. Run tests asterisk in the Test Explorer, you can asterisk click run all to run all tests in your solution. Asterisk select individual tests and click run selected tests. Asterisk right click on a test class or a group of tests and choose run tests. 5. View results asterisk the Test Explorer will show you the results of your tests. Asterisk green checkmark asterisk the test passed. Asterisk red X asterisk the test failed. Asterisk gray question mark asterisk the test has not been run yet. If a test fails, the Test Explorer will provide details about the failure, including the expected and actual values. Click on the failed test to see the stack trace and error message. More nunit assertions. Nunit provides a rich set of assertion methods. Here are a few commonly used ones. Asterisk assert.AreQual, expected, actual, checks if two values are equal. Asterisk assert.are not equal, expected, actual, checks if two values are not equal. Asterisk assert.is true, condition, checks if a condition is true. Asterisk assert.is false, condition, checks if a condition is false. Asterisk assert.is null, object, checks if an object is null. Asterisk assert.is not null, object, checks if an object is not null. Asterisk assert.are same, expected, actual, checks if two objects refer to the same instance. Asterisk assert.are not same, expected, actual, checks if two objects do not refer to the same instance. Asterisk assert.throws exception type, delegate, checks if a delegate method throws a specific exception. Asterisk assert.that, actual, constraint, a more flexible assertion that allows you to use constraints to specify more complex conditions. Example using assert.that and constraints asterisk. Important nunit attributes. Asterisk test fixture, marks a class as a test fixture. Asterisk test, marks a method as a test case. Asterisk setup, marks a method to be executed before each test. Use this for initialization. Asterisk teardown, marks a method to be executed after each test. Use this for cleanup. Asterisk one-time setup, marks a method to be executed once before all tests in the fixture. Use this for expensive initialization. Asterisk one-time teardown, marks a method to be executed once after all tests in the fixture. Use this for cleanup after all tests. Asterisk ignore, reason, ignores a test and provides a reason. Asterisk test case, arg1, arg2, expected result, allows you to run the same test method with different sets of input data. Asterisk test case source, method name, allows you to get the test data from a method. Example using test case asterisk. In this example, the @_various inputs _returns correct sum test method will be executed 3 times, once for each set of test case arguments. Example using test case source asterisk. The test case source attribute tells nunit to get the test data from the add_test_cases method. The method returns an enumerable test case data, where each test case data object represents a single test case. Set name allows you to give the test case a descriptive name in the test runner. Test-driven development, TDD. Consider using test-driven development, TDD, as a methodology. The process is: 1. Write a failing test *, write a test that describes the functionality you want to implement. The test should fail because the functionality doesn't exist yet. 2. Write just enough code to pass the test *, write the simplest code possible to make the test pass. 3. Refactor * clean up and improve your code, ensuring that all tests still pass. This cycle ensures that you write tests that drive the development of your code. Mocking. When testing classes that depend on other classes, dependencies, you might need to use mocking frameworks, example mock, and substitute, to isolate the unit under test. Mocking allows you to create fake versions of your dependencies to control their behavior during testing. This is a more advanced topic, but essential for complex systems. Code coverage. Tools like Coverlet can measure the percentage of your code that is covered by your unit tests. Aim for high code coverage to ensure that most of your code is being tested. However, high code coverage doesn't guarantee that your tests are good. You still need to write meaningful and thorough tests. Best practices for unit testing. Write tests that are focused and small. Each test should verify a single aspect of the unit under test. Write independent tests. Tests should not depend on each other's state. Use setup and teardown to isolate tests. Use meaningful test names. Test names should clearly describe what the test is verifying. Follow the arrange act assert pattern. This makes your tests easier to read and understand. Test edge cases and boundary conditions. Think about the different inputs and scenarios that your code might encounter. Keep your tests up to date. When you change your code, update your tests accordingly. Run your tests frequently. Integrate testing into your development workflow, example run tests after each build. Don't test implementation details. Test the behavior of your code, not the specific way it's implemented. This makes your tests more resilient to refactoring. Test exceptions. Verify that your code throws the correct exceptions in error conditions. Example project structure *. This is a standard project structure, but you can organize your tests as needed for your project. This detailed guide should give you a solid foundation for unit testing with Visual Studio 2022 and nunit. Start with the basics, practice writing tests, and gradually explore more advanced concepts like mocking and code coverage. Good luck.